Alright, welcome to Unit 2. So this is a quadratics unit, quadratic functions, but we are starting with just reviewing polynomials first, and then you might notice there is a quiz, probably next week. And then we actually get into the quadratic stuff. So let's start with our polynomial stuff. We're doing lesson 1 and 2 because they are very, very short. Okay, the first one, adding and subtracting polynomials. Let's start with defining what is a polynomial. So this is a function in the form, oops, let me write that down. A function in the general form. Now, let me write it out first. A of O times x to the power of n plus a of 1 x to the power of n minus 1, a of 2 x to the power of n minus 2, plus and so on all the way until the last number a of n. And now you might be thinking, Miss Park, what the heck do all these numbers or letters mean? Well, this is a general form. So these a's, like AO, A1, A2, and so on till AN, these are just numbers, like a constant number or like a coefficient numbers. These n and n minus 1 and n minus 2 and so on, these are just the exponents on top of the n. And it's written this way just to show that we write it in the descending order. So for example, y equals 3x cubed plus 4x squared minus 2x plus 1. This is a polynomial. Anything with powers of x, like x to the power of 3, x to the power of 2, and x. Nothing else involved, okay? And we've got some constants here. That's a polynomial. Or maybe a simpler one, y equals 3x squared plus 2. That's a simple polynomial. So these are just examples. Okay, and what are like terms? These are any terms that have the same exponent. The same exponent on the variable. So typically the independent variable, and we're looking at x or t, but you could be using any other letters if you want, but that's what we just see often. Let's look at some examples. I'm given two polynomials I'd like us to add and simplify. So collect the like terms basically. Okay, so 3x squared and x squared, those are like terms. If you add them, you get 4x squared. If you add the negative 7x and the negative 3x, you get negative 10x. If you add the positive 5 and a positive 2, you get positive 7. So that's just simply called collecting the like terms when you add the like terms together. Second one, we have to make sure this negative sign is distributed into the bracket before we can add the like terms. So x squared minus 6x plus 2 can stay, but negative x squared, negative minus is positive 6x, and negative 3. Okay, let's collect the like terms again. So x squared minus x squared gives you 0x squared. Negative 6 and positive 6 is again 0x. Positive 2 and negative 3. Negative 1. So your final answer, negative 1. Alright, let's look at a word problem together. Nigel and Petra are hosting a dinner for 300 guests. Cheers Banquet Hall has quoted these charges. So $500 plus $10 per person for food, $200 plus $20 per person for drinks, and a discount of $5 per person if the number of guests exceeds 200. So Nigel has a cost function, C1 of n is equal to 10n plus 500 plus 20n plus 200 minus 5n. Petra's cost function, C2 of n, is equal to 10n plus 20n minus 5n plus 500 plus 200. And the question is, are these functions equivalent? Well, equivalent just means, are they equal? Or are they the same? So, well, let's try and collect the like terms. The first one, C1 of n, if I write it again, so 10n plus 500, I'm going to get rid of all the brackets, plus 20n plus 200 minus 5n. If I add all the 10n plus 20n, which is 30n, minus 25n is 25n. And the numbers 500 plus 200, 700. Okay, C2 of n, Petra's function. Again, I'm going to write it without any brackets. And same thing, if I add all my n's together, so 10n plus 20, which is 30, minus 5n, which is 25n, and you have your numbers, the 500 plus 200, which is 700. And you end up with the exact same function. So I can say, therefore, they are the same cost function. So you can say, yes, they are equivalent, because they're the same. Alright, let's move on to lesson 2. Hopefully that was more of a review, and hopefully number 2, multiplying polynomials, is nothing too new, hopefully. So when you multiply polynomials, you want to expand and collect the like terms. Expand your brackets, and then you collect, or like you add, the like terms. So here are some vocabulary when we multiply and expand. The commutative property just means A times B equals B times A. Yes, these do have a name. It's called the commutative property. You think it's very obvious, but there's a name for everything. So like, for example, like 3 times 4 is the same thing as 4 times 3, which is 12. Associative property means when you have A times B bracket times C, this is the same thing as A times when you do B times C. So when you do A times B first and then multiply C to it, it's the same thing as B times C first and then multiplying A into it. So you can switch the order of multiplying things. Distributive property, when you have A multiplied to B plus C, we draw the little rainbow like arrows, right? We distribute it so we can expand. So AB plus AC, and this is called the distributive property.